Prime factorization is also known as division by primes or product of primes or sometimes even also known as the tree thing. And in order probably to do this, we should probably just review what is a prime number. What is prime? What's a prime number, DJ?
A number that can be multiplied into by 1 digits?
Yeah, well, technically, the technical definition is a number that only has two factors, one in itself. But an easy way to think about it is any number that cannot be divided by anything else. That cannot be divided. Examples of that would be, and we'll start with the first one here, which is 2. Okay, 1 and 0 are not prime. Don't worry about those. And then you've got 3, 5, 7, 11, 13, 17, and so on and so on and so on. Okay, 15's not in there because 3 times 5 is, 9 is not in there, 15's not in there because 3 times 5. Okay, there are other things that go into it. So, what is a prime number? Any number that cannot be divided. Lutz?
Why is it known as the tree thing?
Don't ask questions about things that I don't get to at the end of the lesson. That way, maybe if I answer it, then I don't have to worry about it there. DJ?
Wait, you said any digit
Cannot be divided by another number. But like I said, the actual technical definition is any number that has only 2 factors. That's the technical definition. Okay. Now, prime factorization means that you're taking a number, for example, 6, and you are breaking it down so that it is prime numbers multiplied together. For example, 6 is 2 times 3. Okay? Or if you want to do it as a tree, 2 times 3. Since both of these are prime numbers, we know that this is the product of primes for 6. Okay, and notice 1 doesn't count because you could keep splitting things down into ones forever and it's not going to change anything. Another example here, if I split the number 8 down, well 8, think about what times what gives you 8? 2 times 4. Okay, but 4, 2 is prime, so you can stop with that. But 4 is not a prime number. 4 can be divided by 2 again. So you'd have to break this down again into 2 times 2. Now you can stop when both of these are prime, or all of them are prime. So 8, as a product of primes, is 2 times 2 times 2. If I were to remultiply those 3 again, I would get 8. This is the product. 8 is a product of those prime numbers. So this is it. 2 times 2 is 4, times 2 is 8, and that's what I started with. Christine?
I'm confused.
No, we're not done yet. Don't tell me you're confused until we're completely done. So what you're going to do with this is this. Let's say you're starting with 12, and it said to write that as a product of primes. Okay? And this is why it's called the tree thing. Okay, you say to yourself, okay, what times what is 12? By the way, there's a couple different answers. It doesn't matter, Ariel.
2 times 6.
2 times 6. So, forget about the 12 and you look at the 2 times the 6. Are either one of those prime?
Yes.
2 is prime. So you stop with the 2, but 6 is not prime. So you can do a little shoot off of that and say, okay, well, now what times what is 6?
3 times 2.
3 times 2. Now you look at those little shoot things. Is 3 a prime number? Yes. And is 2 a prime number? Yes. When you get down to all prime numbers, just rewrite those numbers. I have 2 2's and a 3. 2 2s and a 3. This is 12 written as product of prime numbers. And it's called the tree thing because as you look, it looks a little like a tree sort of thing. Alexa?
Now, will we get the same answer if
Yep, if you would have used 4 times 3, you'd get the same answer if that's what you split
maybe
4
4
into.
times 4 times 4?
Either way, yeah. Great?
So do you need to see that tree thing?
I do if they ask you that. Let's do 24. I'll do 24 two different ways just so you can see it there. Let's say you said 24 was 6 times 4. Okay, you look at your little branches there to your tree. It's either 6 or 4. Are they either one of them prime? No. So you can break those down again. What times what is 6? And again, don't use 1 because 6 times 1 is not going to get you anywhere because you can keep doing that forever. Okay, you're going to use 2 times 3 for 6 or 3 times 2. Okay, can those be split up? No. 2 is prime, 3 is prime. And 4 is not prime, so that's 2 times 2. Both of those are prime, so I can stop. And make sure you circle the bottom, because otherwise you'll get confused of what your prime numbers are. 24 is what you get when you multiply 2 times 2 times 2, and I try to write all my numbers that are the same together, so because when I grade them, that's what it's going to look like. And then times 3. 2 times 2 is 4. 4 times 2 is 8. 3 times 8 is 24. So this is 24 written as a product of primes. Now, just for fun, I'm going to split 24 up a different way. Let's say I use 2 times 12. Okay, I can stop with 2 because it's prime, but 12 ends up being 2 times 6. I can stop at the 2, but the 6 isn't prime, so I break down 6 into 2 times 3. And both of those are prime, so I can stop. You get the same thing. You get 3 2s and a 3. Isn't it? Let me give you one to try. What about 36? Find the product of primes of 36. Product of primes of 36. The product of primes of 36. Sammy.
2 times 2 times 3 times 3.
Well, let's see. What'd you break 36 into? 12 times what?
3.
All right, 12 times 3 works. 3 is prime, so you can stop with that. 12 is
6 times 2.
6 times 2. 2 is prime, so you can stop with that. And 6 is
3 times 2.
3 times 2. Those are both prime, so you can stop with them. 2 2s and 2 3s is what your answer is. And I'm sure some of you might have done 4 times 9 to start off with. Either way, you'll still get 2 3s and 2 2s. 6 times 6, still get 2 2s and 2 3s. Either way, did you get 2 2s and 2 3s?
Yeah.
Alright. Alright, now, along those same lines, write this down. Division by primes. Division by primes is doing the same thing, just using a different method. And division by primes, just like it says, means that you are going to divide by prime numbers. And we really need to kind of see the example. Let's do 36 again. Okay. Let's do 36 again. Give you a chance to do that. Division by primes looks like this. You're going to take 36 and keep dividing it by prime numbers till you can't divide it anymore. And it's nice because it's sometimes easier than the tree thing when you get the bigger numbers that you can't think about what goes into. But the best way to start about it is if it's an even number, the easiest thing is always to divide by 2. So I'm going to divide this by 2, which is a prime number. And it's easy to take half of things. Half of 36 is 18. Okay? So I've got 1 2 here. And then I take my new answer, and divide it by a prime number. And again, if it's even, I'm gonna keep dividing it by 2 because it's easy to take half of 18, which is 9. Now 9 is not even and 2 doesn't go into it, but what prime number does go into it? 3, and you get an answer of a 3, and both of those are prime, so you can stop. And if you look, it's the same as the tree thing. I got 2 times 2 times 3 times 3. You keep dividing by prime numbers until you get all the way down to where it can't be divided anymore. But these have to be prime numbers. I could not divide 36 by 6. This won't work because then you'll end up with a 6 at the end, and you can't have a 6 at the end. Okay? Let's
Can we call it the giant cake?
call it whatever you want. I'm going to call it division by primes. Let's look at another example. Let's do 200. Division by primes, again, as long as it's even, I would cut it in half. Divide by 2, half of 200 is 100. Still even, so I cut it in half. Half of 100 is 50. Okay, I can still even, so I can divide it by 2. Half of 50 is 25. I can't take 2 into 25, but I can take, Alexa, 5. And 25 divided by 5 is 5. So by division by primes, the answer I get is all of these. I get 2 times 2 times 2 times 5 times 5. This is 200 written as product of primes.
So the answer I got.
2 times 2, yeah, you can show all of that. 2 times 2 times 2 times 5 times 5. You always want to write them in order because that's how I will give the answer to you. Jacob?
So basically, the multiplying and dividing, you'll get the same answer.
Doesn't matter if you use the product of prime way or the tree thing or any of those, you'll get the same answer. It's all the same thing. Factor trees. Yes, DJ.
So what if we told you like to multiply it, then after something that, then divide it, do we have to like,
I don't know what your question is. To remultiply it?
no, like, would you want us to like, would you like, when we're drawing the multiplication one, do you want us to still draw the addition one since it's just there?
You'll either do one or the other. They'll tell you which one you want to do. Product of primes, or they'll either tell you to use a factor tree, which is the tree thing, or they'll tell you to do division by primes. Either way is good. What else do we got? Take out a blank piece of paper, please.